Hey guys, this is Mr. Bennett, and this is video 11-3. We're going to talk about how to do three-step stoichiometry problems. And if you've already watched 11-2, this next diagram should look familiar. It's not exactly like what we drew yesterday, but all the parts are the same. So what I'd like you to do right now is, as I go through this, I'd like you to add the same information that I add. Okay? So on this left-hand side, we're talking about substance A. And we talked about this yesterday, that in a lot of different equations, you have multiple substances. You can take the information you know about one substance, and you can convert that into information about another substance. Now, let's say, for instance, we had the mass of substance A. We can convert that to moles of substance A if we have the mass from the periodic table. So for instance, if it were water, we could find out the mass of water using the average atomic masses that are found on the periodic table. Let's say that we had the volume of substance A. Well, we could convert that into moles of substance A, assuming that it's a gas, right? So don't forget, for volume to work, it has to be a gas. It has to be at STP. And if that's the case, then it's 22.4 liters for every mole. And finally, if we had particles, so that could be atoms, could also be molecules, or it could be formula units. Really anything that you would count. Okay, if you have things that you have counted, particles, you can convert that into moles by using the mole number 6 times 10 to the 23rd. So it's 6 times 10 to the 23rd particles per mole. And then finally, to get from substance A to substance B, you would just need the coefficients from the balanced equation, right? And so if you have your balanced equation, you look up the coefficients of substance A and substance B, and you're good to go. You can do the conversion. Now, I don't need to fill these in. These values here, or these values that we would use to do the conversion, are the same as over here. So for mass, to get to mass, we would use periodic table. To get to volume, 22.4, and to get to particles, 6 times 10 to the 23rd. Alright, so that kind of reviews the diagram that we looked at yesterday. Now let's talk about three-step stoich problems. Really, it's not that different from a two-step stoich problem. If you can do a two-step, meaning you can chain together two one-step problems, then a three-step is really just a small stretch further. So let's take a look at the equation I have here, our first practice problem. We're going to do this one together. So we have sodium oxide combined with water, which produces sodium hydroxide. Okay, it's balanced. We're good to go. So let's look at the question. It says, how many grams of water are produced if 6 times 10 to the 23 formula units of sodium hydroxide are produced? Okay, well, first I got to look at my given value. So our given value here is 6 times 10 to the 23rd formula units of sodium hydroxide. Okay, based on our diagram, you can actually see it up here, we're at particles, right? And what we need to do is we need to get to grams of water. Now notice that water is a different substance. We were at sodium hydroxide, that's going to be our substance A essentially, and we want to get to water, which is our substance B. Okay, if we look at our diagram up here, well, we need to get from particles to moles. Then we need to get, that'd be moles of substance A, right? Then we need to get to moles of substance B, right? And then we can't see it because it's off the screen right now, but we need to get to the mass of B, right? So essentially these are our three steps. Step 1, step 2, step 3. That's why we call it a three-step stoichiometry problem. To get from particles to atoms, we're going to use the magical mole number, meaning 6 times 10 to the 23rd. To get from mole A to mole B, we're going to use coefficients. And then to get from moles of B to the mass of B, we're going to use the mass from the periodic table. Okay, so that's kind of my game plan, my route, so to speak, that I'm going to take to get to the answer. So let's start with our given value, 6 times 10 to the 23rd, and we're just going to put, it will be formula units, so we'll FU there, and then the substance is sodium hydroxide. Okay, dot in a line, meaning multiply in a line, And then let's see what we got here. Unit wise, we're going to put our old units on the bottom so they disappear. So that's formula units. The substance, don't forget your substances. Remember, getting a good habit of writing the substance every time now. Then we need to get to the units that we want next. Well, we're in step 1 right now, so we're going from particles, meaning formula units, to moles. So it's going to be moles, and we're still dealing with substance A, so it's going to be moles of sodium hydroxide. Right? Next, we're going to go to, actually before we go on to the next step, let's plug in some numbers here, because I know that is something that people get a little concerned about. So remember that it's 6 times 10 to the 23rd particles for every 1 mole. So that means 1 mole is 6 times 10 to the 23rd particles. Okay, so this 6 times 10 to the 23rd I'm using because that's the number we use to get from particles to moles. This 6 times 10 to the 23rd I'm using because that's the given value in the equation. So a little difference there. Alright, so step 1 is done. Let's move on to step 2. So another dot line, right? We need to get rid of moles of sodium hydroxide. So we put that on the bottom. Okay, and then we're going from moles of sodium hydroxide, or moles of substance A, to moles of substance B. So it's going to be moles, and in this case substance B is water, so H2O. And these values here, as we set up on our diagram, are going to be the coefficients. Okay, so if we look at our balanced equation over here, the coefficient for water is 1, so plug a 1 in there, and the coefficient for sodium hydroxide is 2, so we plug a 2 in there. Okay, so that's 1 step, 2 step. Last but not least, we're going to do our 3rd step. We need to get rid of moles of water, so I'll put moles of water on the bottom. And then we want to, let's see, let's go up here in case we've lost where we are. We went from particles to moles of A. We've now converted in the 2nd step to moles of B. We need to get to the mass of B. So that's going to be, mass would be grams of water. Okay. Now, what values are we going to use here? Well, we need to go to the periodic table, right? The mass of water, if you remember, hydrogen has a mass of 1, oxygen has a mass of 16. We have 2 hydrogens and 1 oxygen, so that's 16 plus the 2 hydrogens, which will give us a mass of 18. And the mass of any element on the periodic table is the mass of 1 mole of that element, so hence we're going to put a 1 in front of the mole. Okay? So now our 3 steps are here. 1st step, 2nd step, 3rd step. If we go back and we look, notice formula units cancel out, sodium hydroxide cancels out, moles cancel out, sodium hydroxide cancels out, moles here cancel out, water cancels out, and so we're left with grams of water, which is exactly what they wanted. So we know based on our units everything's going to cancel out, so when we plugged in the numbers in the right spots, we're good to go. So let's look and see what happens in terms of canceling. Well, I kind of set this up nice and easy where 6 times 10 to the 23rd is going to cancel out 6 times 10 to the 23rd. That's easy, right? Then we're left with a 2 and an 18. So this is going to be 1 times 1 divided by 1 times 1 divided by 2, so a half essentially, times 18. So in other words, what is a half of 18? It's 9 grams of water. Okay, so that's our first practice problem. Now the 2nd practice problem I would like you to do on your own right now. Meaning I would like you to take a look at this problem and see if you can solve it. See if you can map out the 3 steps, come up with the answer. If you get stuck, then start the video up again, see where you are stuck, and if you can, once you're unstuck, pause it and see if you can finish things off. Okay, so right now pause the video, try the problem, and then when you're done, start it up and see if you got it right. Okay, so hopefully you pause it and you tried it already, and now you just want to see if you did it correctly. So first thing I'm going to do is I'm going to talk about my game plan, or the path that I'm going to take. And I don't have a lot of room down here, so I'm going to write up here. Okay, so we know that we have grams of NO to begin with. Okay, so grams of NO. And we know based on our diagram that from mass we need to go to moles of substance A, which would be moles of NO. And then once we have moles of NO, we can then convert that to moles of the substance they want, and in this case it's oxygen, so that's going to be moles of O2. Okay, so technically I probably should have looked at where they wanted us, what they wanted us to convert to before I started setting up my game plan, but I know this is a 3-step, and I know that I'm going to need to go somewhere from mass. And remember, based on the diagram, the only thing you can turn mass into is moles of that substance. Then once you have moles of that substance, you can change that into moles of another substance as long as you have a balanced equation. From there, we only have 2 steps right now. We need to get to our 3rd step. Third step is to take the moles of oxygen, convert it into grams of oxygen. So that's going to be our game plan there. So let's go ahead and set it up and see how this goes. So my given value is 120 grams of NO dot line. Now we want to get rid of grams of NO, so I'm going to set that up here so it cancels out. And we know that we want to get to, the only thing in fact that we can go from grams to is moles of NO. Okay. Based on the periodic table, we know that the mass of any element on the periodic table is equal to 1 mole. And if we look at the periodic table, the mass of nitrogen is 14, the mass of oxygen is 16, so that gives us a total mass of 30 for 1 molecule of NO. Now, second step, we want to go from moles of NO, so we want to get rid of those, to moles of O2. Right? And to get these values, we're going to go to the balanced equation. So I find O2. O2 has a coefficient of 5. And then I find NO, which has a coefficient of 4. Plug that in. Okay. Now, third step, I'm going to get rid of my moles of O2. Okay. So I'm right here right now. I've already done 2 problems. Moving on to the third step, I'm getting rid of my moles of O2, and I'm going to grams of O2. And to plug in these values, again, to get to mass, you have to use the periodic table. The mass on the periodic table is equivalent of, or for 1 mole of the element. And then don't forget, with O2, you're dealing with 2 atoms of oxygen. 1 atom is 16, has a mass of 16. 2 atoms would be 32. Okay, so there's my problem set up. Now I just need to do the math side of it. So 120 and 30, I can actually reduce this. 30 goes into 120 4 times. And then notice I spy over here another 4 on the bottom, so I can cancel that out, turn that into a 1. The 4 disappears, and I'm left with 1 times 1 divided by 1 times 5 times 32. Okay, so in other words, 5 times 32 is my answer, which is going to give me 160 grams of O2. If you don't remember what the units are supposed to be, double check that they all cancel out. So grams cancel out, NO cancels out, moles of NO cancels out, moles of O2 cancels out, and I'm left with grams of O2. So those are my units. Alright, so that's the second problem. Hopefully you get it right. Make sure that you complete the whisk, and we'll see you tomorrow.